Now let's look at some examples. To simplify this expression, I'm going to start with the exponents that are outside of the parentheses. I know that each of these exponents that I see outside of parentheses needs to be worked into each exponent inside the parentheses. And I have to think that all of these factors I see, they do have exponents. If I don't see them, they are 1. So as I work in this exponent of negative 2, I either think that these have exponents of 1, that it's 2 to the power of 1, and y to the power of 1, or I just don't forget that this exponent does need to be worked into every exponent inside. I'm really trying to be clear about that. So what's the result when we do that? I'll have 2 to the power of negative 2. This x will now have an exponent of negative 6 as we do the multiplication, and the y will have an exponent of negative 2. And we'll just move right along. Now I have an exponent of positive 2 to work in. This will be 3 to the power of 2. Then we would have x to the power of 2. And this y, exponent of negative 4. Now this is all in the numerator. It is important that we keep numerator and denominator clear. I've just rewritten the denominator because there was no exponent outside of parentheses to work in, and I'm just taking my time with these steps, just trying to do one thing at a time. So a little bit of rewriting. After that first move, I see that I have a fraction, so I open a blank fraction now for my next move, which is that I want to deal with any of these places where I see a negative exponent. And the process is, if I see it in the numerator, then I move it to the denominator, and that's how I can make that exponent from negative into positive. And if I see it in the denominator, I'll move it up to the numerator, and that will make the exponent from negative to positive. And anything that I see that already has a positive exponent, I'm going to keep it where it is. If it's in the numerator, that's where it will stay. If it's in the denominator, that's where it will stay. Okay, so piece by piece, I'm going to decide if it should be moved or if it should stay where it is. Here's 2 to the power of negative 2, so I'm going to move that from numerator to denominator. Just a little cross out just to tell myself I've dealt with that one. X to the negative 6, so another thing that will move to the denominator, x to the positive 6. Y to the negative 2, so we've got to move that, y to the positive 2 in the denominator. And we'll just keep moving. So here's a positive exponent, 3 to the power of 2. That's going to stay where it is, up in the numerator. And if you're wondering, does it matter where the fraction, like why is this 3 to the power of 2 all of a sudden in the middle? I don't have a rhyme or reason most of the time. Just as long as if I decide it belongs in the numerator, I make sure it's there. And the same thing for the denominator, that I don't get things mixed up. But you'll see as we go through the problems, we're still going to be picking and choosing things out. So our order does not really matter. X to the positive 2, so that's going to stay in the numerator. Y to the power of negative 4, we should move that to the denominator. Now we are looking at these factors in the denominator. This is a 5. We know that if we had to see an exponent, it would be a positive 1, but positive. So it's good where it is. It's in the denominator. It should stay in the denominator. Same thing with this x to the power of positive 5. The exponent is positive. Keep it where it is. And lastly, we have y to the power of negative 2. So negative exponent, we'll move that from the denominator up to the numerator. Okay, a quick look at our result. At this point, we have all positive exponents, and we've noticed that some factors had to be moved from numerator to denominator or vice versa. We actually went through and moved anything that had a negative exponent. My next step, I'm again going to open up a blank fraction here and begin to evaluate these numbers. 3 to the power of 2 is 9. I kept that up in the numerator. 2 to the power of 2 is 4, and then we also have a 5. I need to do that. Multiplication, 4 times 5, 20. And since those factors are in the denominator, that 20 needs to go in the denominator. Next, I'm going to combine the variables. I'm looking at x squared on top, and in the denominator, x to the 6th and x to the 5th. So let's first think about our total x's down here in the denominator. 6 and 5, we have 11. We added those exponents, and now when we're looking at this fraction, x squared over x to the 11th, that's where we're thinking subtract. That difference is 9, and I've got many more x's in the denominator, so that x to the 9th belongs in the denominator. And I'll do something similar with y's. I could look and I see that I have 2y's with 4 more y's, so I have 6y's in the denominator, and up here in the numerator I have 2y's. So 2y's with 6y's down here, I'll get some canceling, and the difference would be 4y to the 4th. And if you said, well, we used to be able to cancel factors, could I just say y squared should cancel with that y squared? And absolutely, and it'll always work. That fits in nicely with all of our rules. We still see that same result, y to the 4th, after our canceling of the y's. And now we're pretty much done. I do a quick check to see that I don't have any exponents outside of parentheses anymore. That was our very first move. I want to make sure that I don't have any negative exponents, and I want to make sure that this fraction is simplified, and it is, so we're finished. I'll just rewrite it so I don't have this massive fraction bar, just a properly sized fraction bar. 9 over 20 x to the 9th y to the 4th. I need to clarify something. This would not be right if you're thinking 9 over 20 times x to the 9th y to the 4th. So to have it out here on the side is really saying that it's in the numerator, and that's not what we want to say for this problem. So this is an answer that should be avoided, and this is an answer that we like. Here's our next example. I'd like you to pause the video, try this one, and then restart the video. We'll look at the answer together. Our first move is, again, exponents outside of parentheses need to be worked in to each exponent inside the parentheses. Don't forget, even these numbers, they also have exponents. There is an exponent of 1 there, and that should not be ignored as we multiply these exponents into each exponent inside the parentheses. That will take us to 4 to the power of negative 2, x to the power of positive 10 when we multiply negative 2 times negative 5, and this will be y to the negative 6. This set of parentheses, we're working in a positive 2. This will make 2 to the power of positive 2, x to the power of negative 8, and y to the power of positive 10. Our next move is moving these factors that have negative exponents, so we'll be probably seeing some fractions now. I'll open up a blank fraction and begin to move these factors that have negative exponents. This was 4 to the power of negative 2, and remember, when we see a problem where everything is on one line, it's as if they are all in the numerator. So I'm moving this from numerator down to denominator, but this x to the power of positive 10, that has a positive exponent, so it does not need to be moved. It will stay in the numerator. And we'll just keep going down the list. Y to the power of negative 6, we'll move that to the denominator. 2 to the power of positive 2, we'll keep that in the numerator. X to the negative 8, we'll move that to the denominator. And y to the power of positive 10, we'll keep that in the numerator. Next, I'll open up another blank fraction and begin to evaluate these numbers. We have 2 to the power of positive 2 in the numerator, so I've brought over a 4 in the numerator. We have 4 squared in the denominator, that's 16 in the denominator. Now looking at the variables, the x's, I have x10 over x to the 8th, so that will leave us with x to the power of 2 up in the numerator. And now we have y to the 10th over y to the 6th. That's a difference of 4, and we see that we have more y's up in the numerator, so that y 4th belongs up in the numerator also. We're ready to just clean up this fraction. We don't have any parentheses. We don't have any negative exponents. Let's just make sure, can we simplify this fraction 4/16? And yes, we can. That's 1/4. So as I rewrite this fraction, I have in the numerator 1x squared y 4th, but remember, when those coefficients are 1, we usually let those go. So I have just x squared y 4th over 4. Now we need to look at some examples where we have more negative coefficients. And before we get to problems like that, let's just do a quick recap of some important info about negative numbers with exponents. There's a big difference between these two expressions that we have. Let's start with this expression down here. I see this 2 is outside of the parentheses, so it is telling me that this is negative 3 times another negative 3, a total of 2 times. And negative times negative would equal positive 9. But in this expression up here, the exponent is not working on a set of parentheses. It's really only working on the 3. So if I think about repeated multiplication, it's really just a 3 that is repeated. And that negative sign there, it's really there just once. And that gives us an answer that is negative. We have to treat this exponent as if it is separate from the negative sign. That gives us this negative 9 for an answer. Another way that we could look at these problems is that when we see a negative number, we can actually break any negative number up into a multiplication of negative 1 and the positive form of that number. So a negative 3, I could call it negative 1 times 3. And that is often useful for using our exponent rules that we've been working so far. If I look at this negative 3 as negative 1 times 3, and the exponent is on the parentheses, so it is both of these factors that have the exponent of 2. And then if I use my rule where I work in this exponent, I'll see that I do have the negative 1 twice and the 3 twice. This is helpful because when we look at a negative 1 with some exponent, our only possible answers are positive 1 or negative 1. And it all depends on what is the exponent. This all is related to our rule about multiplying negatives, that if you have an odd number of negatives, it makes your answer negative. And if you had an even number of negatives, it would make your answer positive. So we just look at this exponent and see, oh, 2 negatives, our answer would be positive. And then I move on and look at this 3 squared, and I know that's 9, so I see an answer of positive 9. This is an approach that I'm going to use in some of our upcoming problems. It's something that through experience I know it helps me stay accurate with the negative signs. So when I see negative coefficients, I'm going to break them up into this multiplication of negative 1 times the number. This is a good example for us to look at where I do that exact move. Now, the problem still fits into our other problems that we've looked at so far, meaning my first move is, let's take this exponent outside of parentheses and work it in. But I'm also, because I see a negative 2, I'm going to think of this negative 2 as negative 1 times 2. And now when I'm working in this exponent of 3, I need to hit both of these, hit the negative 1 and hit the 2. It might seem like we're doing a little bit of extra work, but I think it's worth it. I feel a lot more comfortable with keeping track of my negatives when I do this move, so that's why I encourage it. Let's finish working in this exponent of 3, so that will make this x squared into x to the 6th. Let's move over to this set of parentheses. We're working in an exponent of positive 5. I see a negative 3, so I'm going to do that same move and rewrite it as negative 1 times 3, and each of those gets that exponent 5. And moving over to the x, this will become x to the power of 10 as we're multiplying these exponents. My next move would be to move some of these factors that have negative exponents, but everything is okay. The negative ones that we see here should absolutely not be moved, because in terms of do we move it or not, that all is based on our exponent. If the exponent is negative, that's when we move it. And if the exponent is positive, it stays where it is. So I'm looking at these and I see positive exponents, so I'm not moving anything into a denominator. Let's begin to put our answer together. Let's start with the negative ones. So looking at the total negative ones that we have 3 here and 5 here, so we have a total of 8. So with 8 negatives, would that make our answer negative or positive? Well, 8, an even number of negatives, makes our answer positive. So I've taken care of the negative ones just by determining that the answer is going to be positive. And now those are done. And I can move on to these other numbers. We have 2 to the third is 8, and 3 to the fifth is 243. And I'll even go ahead and multiply those together, 1,944. Now let's put together these x's, x to the 6th with x to the 10th. That's x to the 16th. And we've taken care of all numbers and variables. We don't have any negative exponents. We don't have any fractions that need to be simplified, so we're finished.